Good morning, dear student. In previous lecture, we already discussed the IR bands in carbonyl complexes. So, in today's lecture, we are very much interested to find out the number of IR bands for various geometry when the CO ligands are attached to the metal atom. If you consider the first one, that is the number of carbonyl ligand number of carbonyl ligand is 6. Okay, if the number of carbonyl ligand is 6, then we know that the geometry is your perfect octahedron. So there is a total 6 carbonyl is there, and we know that this octahedral geometry octahedral geometry is of higher symmetry complexes. All these carbonyls are equivalent, and we get only one IR band. For this carbonyl complexes. So whenever there is a 6 carbonyl which is attached to the metal atom, all these carbonyls are terminal carbonyls. All these carbonyls are equivalent carbonyls, and we get only one IR bands. Okay, so this is all about when the number of carbonyl is 6, the geometry is octahedron. Let us discuss the second, that is the number of carbonyl ligand is 5. So you can write here the number of CO ligand. The number of CO ligand is 5. Whenever the number of CO ligand is 5, then if you consider there is a 2 coordination number. Okay, that is when CO ligand is 5, then the geometry, we know that the geometry is perfect trigonal bipyramidal geometry. So in this case, we considering the 2 coordination number, that is coordination number 5 and coordination number 6. Okay, so for octahedral we consider only one coordination number, that is coordination number 6, because there is a total 6 carbonyls, no other geometry is there. But if you consider the number of CO ligand, that is carbonyl ligand is 5, in that case for coordination number 5, the geometry is trigonal bipyramidal, and we know that trigonal bipyramidal. And when if you consider the coordination number 6, and one of the site is vacant, so there is a total 5 carbonyl, and one site is vacant or it is replaced by another ligand, then the geometry, or we can consider the shape, it is not geometry. The geometry is octahedron, but the shape is your square pyramidal in this case. So don't get confused between the geometry and the shape of the complexes. Okay, whenever there is a coordination number 6, the geometry is octahedron, and whenever there is a coordination number 5, then the geometry is trigonal bipyramidal. But if you consider there is a total 5 carbonyl, and if the coordination number is 6, then the geometry is octahedral, but the shape is square pyramidal. So if you consider both these two structure, that is the first one, that is trigonal bipyramidal, that is we are very much familiar with this trigonal bipyramidal geometry, that is 3 carbonyl in equatorial plane and 2 carbonyl are axial. And if you find out the point group, or to find out the number of IR bands for this trigonal bipyramidal geometry, then we know that if you consider this carbonyl which is axial, and if you consider this is your C3 axis, okay, it is a symmetric molecule, and in which the axis which is present, that is principal axis which is present, is C3 axis. So after C3 rotation. Okay, C31, C32, C33 rotation results into the identity operation. So you are all familiar with this principal axis and identity operation. So after one C3 rotation, second C3 rotation, the third C3 rotation results into the identity operation, and therefore the principal axis is C3. And again, the perpendicular C2 is also present. The perpendicular C2 is also present in this trigonal bipyramidal geometry, and therefore the point group of this geometry is D3H. Okay, the point group of this geometry is D3H. And if you consider, in this case, we get only one IR band. We get only one IR band. We get only one IR band at high temperature. We get only one IR band at high temperature. So no doubt all these carbonyls are equivalent carbonyl, but we know that this carbonyl, okay, having a trigonal bipyramidal geometry, they shows fluxonial behavior. Means the carbonyl which is axial goes into the equatorial position, and the equatorial carbonyl goes into axial position, and therefore uh, at high temperature we get only one IR bands. So we can write here, at high temperature, we get only one IR band, because all carbonyls are equivalent carbonyls. Only one IR band at high temperature. All carbonyls are equivalents. So at high temperature means at room temperature, and at low temperature we get two IR bands for this trigonal bipyramidal geometry. So we get two IR bands at low temperature, because one IR band due to this axial carbonyl and another IR band due to this equatorial carbonyl. So at low temperature we get two IR bands. Okay, and the point group is D3H. If you consider the coordination number 6, in which the geometry is square pyramidal, the ligand is same, that is total 5 CO ligand is there. And if you draw the structure of this complex, then we get like this. This is carbonyl, 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 and this side is vacant. So if you consider the principal axis or the point group of this square pyramidal shape, when the number of CO ligand is 5, then in this case the principal axis is your C4 axis. Principal axis is your C4 axis. So after 3 C4 rotation, the next C4 rotation results into the identity operation, and therefore the point group of this square pyramidal shape, when there is a total 5 ligand, is your C4 point group. And we know that whenever there is a C4 point group, then we can calculate the number of IR bands by using the formula. So number of IR band, which is equal to n minus 2. So n is nothing but your carbonyl ligand. So there is a total 5 carbonyl, so 5 minus 2, so we get total 3 IR bands for this square pyramidal shape. Okay, square pyramidal shape. So the point group is C4V, and the number of IR bands, you can write here, number of IR bands is equal to n minus 2. So the point group is C4V, therefore number of IR band is n minus 2. So in this case we get 5 minus 2, so we get total 3 IR bands. No doubt total there is a 5 carbonyl, but in actual IR spectra we get only 3 IR band for this square pyramidal shape. Okay, so whenever we considering the number of CO ligand is 5, so in this case there is a two coordination number. One is coordination number 5, another is coordination number 6. So for coordination number 5, the geometry is trigonal bipyramidal, the point group is D3H, and at high temperature we get one higher band. At low temperature we get 2 higher band. For a square pyramidal shape, the point group is C4V and the number of higher band is n minus 2. So we get total 3 higher band for this square pyramidal shape. Let us consider the next one when the number of CO ligand is 4. So let us consider the next one, that is number of CO ligand is 4. Number of carbonyl CO ligand, number of carbonyl is 4, and we know that whenever there is a coordination number is 4, so in this case also we discussing coordination number 4, coordination number 4, coordination number 5, and coordination number 6. Okay, so whenever the coordination number is 4, the geometry is perfect tetrahedron. The geometry is perfect tetrahedron. So in this case we know that. So this is the case, that is, if you consider this is the CO and there is another CO. So when you consider the number of CO ligand is 4 and coordination number is 4, then the perfect geometry is tetrahedron. In this case, all these carbonyls are equivalent carbonyl. All these carbonyls are equivalent carbonyl. The point group is tetrahedral, and therefore we get only one higher band. Only one higher band. Only one higher band. So in this case, we get only one higher band. Only. Okay. So you can write here. For this, we get only one higher band when the geometry is perfect tetrahedron. In the second, that is when the coordination number is 5. If you consider the coordination number is 5, means there is a total 4 ligand, but the coordination number is 5, and we know that for coordination number 5 the geometry is trigonal bipyramidal. So we are arranged this 4 carbonyl in such a way that so what is the possible structure for this 4 ligands, 4 carbonyl in coordination number 5? That is, we know that so we get this, that is 2 carbonyls are axial, 2 carbonyls at equatorial position, and one site is vacant. So this is one of the possible structure when the coordination number is 5, that is trigonal bipyramidal geometry is there and the ligand is 4, so one site is vacant. Another possible way is that the second structure, so we are considering the second one. So this is your first. Okay, so here we can write. So 4 we already discussed, that is perfect tetrahedron. We already discussed coordination number 5. So there is a possible 2 structure. One, that this is your metal, 2 carbonyls are axial position, 2 carbonyl at equatorial, and one there is a vacant site. One vacant site should be there. And the another possibility is that the 3 carbonyl at equatorial plane, and there is a 1 carbonyl at axial position, and one site is vacant. So this is the case when the coordination number is 5. Okay, and for coordination number 5 the geometry is perfect trigonal bipyramidal, but we get 2 cases, we get 2 structure in which the 2 CO ligands are axial, 2 CO ligands are equatorial, while in second structure, so if you consider the structure A and this is structure B, in which the 3 CO ligand in trigonal plane and 1 CO ligand is axial. So if you consider the point group for this 2 structure and the number of higher bands, so in this case if you consider, if you pass the axis like this, and if we observe after passing the principal axis, okay, after passing the axis from the center, okay, so it will divide the molecule, or it will divide this complex into two equal half, and therefore the principal axis is present, that is your C2 axis, and the point group of this structure is C2V. And we know that whenever the point group of the complex is C2V or CS, then the number of IR band, which is equal to the number of carbonyl. So in this case, total 4 carbonyl is there, so we get total 4 IR band, total 4 IR bands for this complex, when 2 CO are axial and 2 CO are equatorial. The principal axis is C2 and the point group is C2V. So whenever the point group is C2V, the number of IR band, which is equal to number of carbonyl, and we get total 4 IR band. If you consider the second structure, okay, when there is a 4 carbonyl, out of that 3 are in trigonal plane and 1 is axial. Again, if you consider, okay, this is your axis, then it is very simple, like BF3 molecule is there. Again, this all 3 carbonyls are in trigonal plane, so the angle between them are 120 degree, okay, 120 degree. So the principal axis is your C3 axis, the principal axis is your C3 axis is there. In this case, the principal axis is your C3 axis, but the perpendicular C2 is absent in this case, and therefore the point group of this structure is C3V. And the number of IR bands, we know that whenever the point group is C3V, the number of IR band is n-1. So total 4 carbonyl is there, so 4 minus 1, we get total 3 IR bands. We get total 3 IR bands for this structure. We get total 3 IR bands for this structure when we considering the coordination number 5. So coordination number 4, that is perfect tetrahedron. Coordination number 5, trigonal bipyramidal. So it having a 2 possible orientation, one having C2 point group, so total 4 IR bands, and one having C3 point group, total 3 IR bands. Again, if you consider when the number of CO ligand is 4 but the coordination number is 6, coordination number is 6, again we get 2 possible orientation or possible structure. One is trans and another is cis. So if you consider, this is your carbonyl, and the 2 sides are vacant, so this is your trans complex. Okay, this is considered as a trans complex. Okay, this is like ML4X2. So L is nothing but your carbonyl and X is your remaining ligands or vacant site if you consider. Okay, another ligand is there. So this is your trans complex, and the one more possibility, that is the complex is your cis complex. The complex is your cis complex, means like this. Okay, if you consider, this is your carbonyl, okay, this is your carbonyl and this is also your carbonyl. Okay, like this. So this is your cis isomer. So this is your trans isomers and this is your cis isomer. So in this case, the principal axis is C4 axis, and the perpendicular C2 is also present, and therefore in this case the point group of this trans isomer is D4H, and we get only one IR band. In this trans isomers, those having point group D4H. But if you consider the cis one, again, if you pass the axis, again it will divide the molecule into 2 equal half. So the point group of the cis isomer is your C2 point group, and whenever there is a C2 point group, we know that the number of IR band, which is equal to the number of carbonyls. So total 4 carbonyls is there, so we get 4 IR bands for this cis isomers, 4 IR bands for this cis isomers, and we get one IR band for this trans isomers. So whenever there is a 4CO ligand, then there is a coordination number 4, 5, 6. So the 4, the perfect tetrahedron, we get number of IR band is 1. When the coordination number is 5, then we get two possible structure. One we already discussed, that is 2 CO are axial and 2 CO are equatorial. The point group is C2V. The number of IR band is 4. Again we discuss out of that 3 CO in trigonal plane, 1 CO in axial position, so the number of IR band is 3 for coordination number 5. For this coordination number 6, we discuss that the trans isomers and cis isomers. Okay, so you should keep in mind trans isomers and cis isomers. For trans, the point group is D4H, and for cis, the point group is C2V. Okay, so we get 1 IR band for trans and 4 IR band for cis isomers. Okay, let us discuss the next one, that is when the number of CO ligand is 3. The number of CO ligand is 3. The number of CO ligand is 3, and the coordination number is in this case 4. Okay, coordination number is 4. So 3 ligands and coordination number is 4. Coordination number 4 means it is perfect tetrahedron. So one site is vacant and the 3 ligand is there. 3 carbonyl ligand is there. Okay, and if you consider this molecule, it is looking like ammonia. If you consider this side, if you consider it is as a lone pair, so it is look like ammonia molecule. So it having the point group C3V, and we know that the number of IR bands for C3V point group is n minus 1. So n is nothing but your number of carbonyl. So n minus 1, it becomes 3 minus 1. So we get here 2 IR bands. So total 3 carbonyl minus 1. So we get 2 IR band. Okay, let us consider the second, when the coordination number is 5 and the ligand is 3. Coordination number is 5 and the ligand is 3 ligand. So what is the possible orientation or possible structure? The first one, that is all these 3 ligands are at equatorial plane and the 2 axial positions are vacant. In this case, the molecule is symmetric, and if you consider the principal axis is C3 and perpendicular C2 is also present, the point group is D3H. So in this case we get only 1 IR band. So in this case we get only 1 IR band. So this is the possibility. Again, one more possibility is that the second possibility is that the 2 CO ligands are axial position and 1 CO at equatorial, and the 2 equatorial positions are vacant. And again, if you consider, if you pass the axis from this m by CO, then it divides the molecule into 2 equal half, and therefore the point group of this isomer is your C2V point group. And for C2V point group, the number of IR bands is equal to the number of carbonyl. So number of IR bands is equal to 3, because the number of IR band for C2 point group is equal to the number of carbonyl. So total carbonyl is 3, therefore number of IR band is 3. So the first one is D3H, so we get only 1 IR band because all carbonyls are equivalent. So in this case we get total 3 IR bands. It indicates all these 3 carbonyls are different. Okay, so this is the case when the coordination number is 5. And the last one, that is when the coordination number is 6. Okay, the number of ligand is 3 but the coordination number is 6. And if you consider the 2 possible, so many times the question is asked on this coordination number 6. Okay, these isomers, one is considered as a facial isomer, another is considered as a meridional isomer. So what is the difference between this facial and meridional isomer, and what is their point group? So this is, if you consider all these CO ligands like this, and this uh, all other sites are vacant, means all these CO uh, cis to each other. All these carbonyls are cis to each other, and therefore this isomer is considered as a facial isomer. Facial isomer. Facial isomer, and the point group of this facial isomer is C3V. C3V, and we know that whenever the point group is C3V, the number of iron band is n minus 1. So for C3V, it is the number of iron band n minus 1, so we get 3 minus 1, so we get 2 iron band for this facial isomer. The point group is C3V, so you should keep in mind. And the second, that is your meridional isomer, in which 2 CO ligands are trans to each other, and 1 CO, if you consider, it is cis to each other. 1 CO, it is cis to each other. Okay, so in this case, this is your meridional isomer. Meridional isomer. So in this case, the point group is your C2V point group. The point group is your C2V point group, and we know that whenever the point group is C2V, then the number of iron band is equal to the number of carbon. So total there is a three iron bands in this case. So total 3 iron bands in this case. So facial isomers having 2 iron band, and meridional isomers having 3 iron bands. In the next lecture, we discuss the remaining points of this chapter. Thank you.